Hello, buddy. Can you hear me? Hmm. Perfect, perfect. So I think the broadcast has started. Let me quickly go to my channel for a few points. Hmm. Okay, so I will quickly check if the voice quality is working. Hello. Hmm. Can you hear me? Oh, can you hear me? It's working, but it's just the a bit far. I need to go like this, and then it should be fine, right? No, hands are coming like this. Hmm. Okay, perfect. This is good. Okay, so we need to start with the W3 and we'll start with one more. AWS. So let's copy this. Create A3. We're gonna continue foundation. What foundation we're gonna lay? We're gonna lay. uh, we're gonna lay foundation, but what kind of a foundation we're gonna lay? Oh, that's very interesting. We're gonna lay foundation of role and concept. Perfect. And let me increase this one and paste this thing. And it should come here as per my understanding. It should be this big enough. Perfect. I think there's something I can do. So I have opening on the separate one. I can simply open here. Nope, I don't want to open this one, but rather channel. Let me open this file. Now I can watch from here. um, I can get a better understanding, like if everything good or not. Okay, perfect. So let's keep it there. Come here, and now we need to start our Pomodoro. It's already like 1 hour, so today we're gonna have only three 115. Yep. Pomodoro, Pomodoro. Yeah, focus this one. Let's just start. Okay, so first session we're gonna do is to recap what we learned so far. Perfect. So we are in the series of AWS data engineering certificates exam, and we know that we're gonna start with very basic. So we started doing a sub module, and in the sub module we are doing a project, a course that is given that is already being we already enrolled it. That is data engineering on AWS. Perfect. So good. First thing first, we don't need this thing. We will go here. Let's quickly do a revision of like 25 minutes. So first thing is we are what we are doing. We are preparing for AWS data engineering or data engineer examination. Okay, DE AA for associate and category CA01. This is the exam we are preparing for. On here, the exam gonna test your skill sets as a data engineer. Okay, we are preparing for this one, and we understood that while preparing for this exam, we're gonna have four major things that we need to learn as part of this one. First one is data ingestion, and second, data ingestion and transformation. Second thing that we're gonna learn is data management. Third thing we're gonna learn about data operation and support. And fourth and finally, we're gonna learn about data security and governance. Perfect. So these are the four major operational skill set that AWS is gonna test us also. Okay. So before we proceed, we need to understand two things. Okay, and the relationship between them, and that's very crucial for us to even before we start anything out here. So what is that thing? The thing are quite simple. We need to understand what is AWS is, what is data engineer or who are data engineer, and what's the relationship between these two. Okay, let's start with first data engineer. Okay, if we look here, we understood that data engineer so far that we learned is data engineer are responsible people who convert or transform data from raw to insightful information. These are the people who are responsible to play with the data, and what they play, they convert or they transform raw data into insightful information. That's the core responsibility of data engineer. Perfect. And how they perform it during this process, they need to do several key steps. Several. Okay. And what are those? Those are nothing but a role and responsibility of data engineer. But we won't go right now. We will go slowly. But before that, we need to understand few more things. What is AWS? AWS is your Amazon Web Service. So very quickly, Amazon itself is a company name. I think most of the people use their services as e-commerce. Okay, they provide the e-commerce services plus they provide services to the data engineer or computer science engineer or software engineers. Okay, so Amazon is nothing but the company name. Web is like they provide their service online, like how you do the delivery online, right? How you place your order online, how you place your delivery order online, how you talk to the people on Facebook, Instagram, or some other places is online, right? So web means online. They won't come to your place physically. They will be available directly through website. That's why it's called web. And services is the service they provide and they charge money for that one. So Amazon provides services on their website and that's why they name it AWS. Amazon, when provide services on web application, they call this ecosystem as AWS. Very simple, right? Now we understood AWS provide the services and data engineer are the people who are key responsibility is to convert raw data or the uh, raw data into insightful information. That means when it convert a raw data into some meaningful information, he need to perform operations. Okay, for this one, he need maybe software. He might need resources. He might need XYZ. Okay, for this thing, and these things are being provided by AWS. Therefore, those data engineer who convert their raw data into insightful information using AWS are called AWS data engineers. And that's why we are going for their examination because we want to utilize these web-based services to perform data engineering tasks. Perfect. So now we're going to ask us ourselves that if that's the case, what are the responsibilities of data engineer? Perfect. So okay. Okay. So before we proceed this one, we need to understand few more things. First one is we we as individuals we are preparing for our AWS data engineering examination that certified that we can perform data engineering tasks on AWS. That's simple, right? Because AWS is cloud-based or web-based services. So a lot of companies are using them as their product or as their, you can say, what? They are using or leveraging AWS to perform the things, and that's why they're looking for the people who can come into their team and start using AWS to perform data engineering tasks. Okay, so that's why most of the people they don't look for data engineer. They look for people who can perform data engineering tasks on AWS. That means AWS data engineers. That's why we are preparing for this exam. And to perform or to get certification of AWS data engineer, we enroll ourselves in a course. But we understood if we have to crack this one, we need to do a prerequisite course that is data engineering on AWS. So that we are doing it. And it is divided into 5 segments. First one is foundation, that gonna tell about who are data engineers, what are the services they use, and so on. Perfect. Second one, we're gonna learn about storage. It can be your data lake or it can be data warehouse. Third one is how they process the data, data processing. Okay, data processing is it either can be batch or it can be your stream. Okay, so when you look at this one from this broader perspective, data engineer as an action, they do two things. First one is data storage, and second one is data processing. These are the major tasks they perform. Out apart from this one, there are other tasks as well, but these are the major tasks they perform at a given point of time. Okay, so if you look at this, and these are the 5 we're gonna learn, and right now we are doing this one. So quickly. Okay, so now outline of the course is done. Now finally we get into the section 1 of this course, that is foundation. And foundation gonna highlight or teach us what are the role and concepts that data engineer should know at given point of time when they utilize AWS as a data engineering services or data engineering task. So we need to understand by ourselves who are data engineers, and we already answered this one. Data engineers are the engineers or the people who are responsible to convert or transform raw data into meaningful insights. Their major task consists of the major task that like very core thing that they have to do is data storage, and second one is data processing. Obviously, if they are converting raw to process data, so they need to do data processing. But after that or before that, they need to store it somewhere. That's why they are also responsible for data storage. Okay. So if you look now, if you look from broader perspective, this is the like if somebody asks us who are teachers, these are the people who teach the student, right? This is very generic, and this is also generic. But if somebody asks you what are the tasks, what are the functions that data engineer has to perform, there are five things they perform. First one is data ingestion. Second one is your no data ingestion is should be preparation, because if they don't prepare it, there's no point of storing it. The first one is your data storage. They are responsible for design, develop, and maintain data storage. So they are responsible for this time. Why and how? Let me take you an example. If the data that is coming to our project that we need to process it, we understood that the data is Excel. And this kind of a Excel can be stored in data warehouse and database, because there you can perform more tasks far more effectively and easily compared to other storage. You will definitely go with that storage. And then you need to create the table, you need to create the structure there, you need to create that use case scenario, you need to create that mapper and reducer, mapping between the tables and relationship establishment, everything. So you are responsible for that one. That's why data storage, design, develop, and maintain infrastructure, data storage. Once this is done, you know about what kind of a data are coming and how they're gonna store it. Then you have to do is to bring the data into your system. That is called ingestion. Then you have to do is processing, data processing. That is called distillation. But you can say transformation, data transformation. Perfect. Fourth one, you are responsible for automation. I think cataloging. 336. Okay, cataloging, catalog, and document. So once you get the data, you need to create documentation or catalog that what kind of a data you bought, what kind of the column, what kind of data set you are using or is available for any given point of time. So that's why this is also responsibility of data engineer to maintain and document a catalog of the entire workflow or the entire data set that is being processed through this workflow. I think I have done this one as well. And then after this one is, see, you have created the code, you have created whatever it is needed to perform this one, but at times, no, not all, but majorly this task should be performed automatically, else you have to come manually, trigger the job or execute the job every time. It's not possible. So that means you need to automate the process, automate the data workflow. That when you make sure that the data automatically flow even if you're not there, it just trigger a mechanism and automatically it started working. Mechanism can be on multiple bases. It can be like time based, that every hour it execute, every week it execute, every once a day it execute. It can be one thing. Second thing can be event based, like somebody drop a file, then entire process will start, or something happen and then it has to start. So it can be event based as well. Now the fifth one is ensure data. So now everything is done. We always need to mention, okay, ensure that the data quality at a given point of time is maintained, and the data governance is always given preferences or is always a top priority. So these are the six rules as a data engineer you are responsible for. First one is storage design, second one is ingestion, third one is transformation, fourth one is to document and catalog the dataset or the entire workflow. Fifth one is to automate the entire system so that manual interference can be reduced to none to zero. And last one is ensuring data quality and data governance. So day that was day one. It's all about the day one. Now we will move to day two, and it is interesting because in the day two, we understood that as a data engineer, who he is gonna work with. The first one, the person who gave the chain of thought, like who proposed the idea of the project, is CDO, Chief Data Officer, who then with data architect talk with these different stakeholders of the data, try to retrieve the information like where the data is, how the data is available, everything alongside with data scientist who propose that what kind of a data is needed with data architecture. On this one, this goes to the corresponding stakeholder and get the information that whether they have this kind of a data or not. Perfect. And alongside one data engineer accompany them to understand which are the sources. If it is true, they have to connect and get this data. That means if they need the permission, everything, they will be they are requested or they are liable to get those things. Now data analyst is done, data scientist done, data engineer is done, but there's one more is data security officer because he will guide them like which kind of data is sensitive, which data is insensitive. You can bring it, which you cannot bring it. If you bring them, you need to ensure how you are making sure in your program that it is not being read or it is not being discovered by anyone. Yeah. So one, two, three, four, five. So far five people, six people you are with. One name I forget is data analyst. These are the people who will be responsible at the end of the day to showcase what is the progression and what is the impact of this is made through graphical representation, visual representation for the stakeholders. Okay, now after this one, we understood about with whom they work, but now we do. Perfect. Now we are done with this one. The seventh thing that we learned here is data discovery. So this is the very initial phase. Okay, before the pipeline or anything is built, this has to be performed for the for the process or the project to come into existence. Okay, how it happens? Let me first take a question. If somebody have a question or somebody join. Where I'm keeping it. Okay, so nobody joined. Okay, after that, there also nobody joined, so we can move. That's fine. hmm Okay, so what is data discovery? Data discovery is the process of identifying, locating, and understanding data sources that are relevant to the business and need for analytical code. Okay, so data discovery, uh, I think it should not. Data discovery is finding, accessing, and profiling database file. Typically involve file TPA data is that useful and relevant to the business requirement, profiling the data, checking for the competence duplication and logging. The third one is the goal is to answer the question, do we have the data we need? Oh, But again, then the five step, why they came in one business value. Okay, so what is data discovery? The very first thing we do as part of the project to start is to start with data discovery. So data discovery is a phase where we try to identify and locate the data that we needed for our uh, project to complete. This is the basic thing. So if you look here as well, data discovery is the process of identifying, locating, and understanding data sources that are relevant to the business and need business need or analytical goal. Right? So we just need to have identify those data sets and locate those data sets that are essential, or these are the data sets that are gonna help us to complete the project. Perfect. Any question on this one? I think no. Let's move it. If that's the case, what's next seventh? So if you look here, what it says here, it typically involves finding where data lives, understanding the structure, format, and quality of data, accessing whether it's useful or relevant to the business requirement, profiling the data. Checking for the profiling the data means checking for completeness, duplication, and anomaly relationship between entities. The goal is to answer the question like, do we have the data we need, where it is, and what does it look like, and is it trustworthy enough to use it? This is beautiful. This is beautiful. So data discovery is all about answering us question whether we have the data that we needed with the proper quantity and quality that will enable us to complete this project and or enable us to achieve our business requirement or our business objective. Okay, do we have that one? So in order to answer this one, whether we have it or not, we follow five-step process. Five-step process of data discovery. First one is business value. So this is nothing but to present your idea to the stakeholders and then answer, does it benefit the business or not? Simple. What do you want to do and how it benefit the organizations? This is the first one. Once we get the business approval, okay, we approve your idea, your project theme. You go ahead. We will bill your billing. Or we are fine with investing the money into this project. Then the second thing come identify your consumer. So ultimately, if business is done, we need to understand who are the people that gonna consume the data. Okay. Once this is done, we need to identify the data sources that will be useful in order to achieve the success of this project. Once it's done, data sources, then we need to understand data storage where we gonna store it, and fifth one is data processing. Okay. So these are the five steps that we follow. We will be able to complete the data discovery, or basically it will become end-to-end process. Okay. So how and what we are doing first, we need to get the business on alignment that this is my idea and this is gonna benefit the business on these parameters. If they agree, they will go ahead, they will invest. The second thing you need to understand, if this is my project, obviously they're gonna be end consumer. That's why I'm creating, right? If I'm creating something for business, there will be definitely end user who's gonna consume it, and they will be the one who will be paying the money to us for this project, right? Than the end user. Third one is, let's continue. It's not gonna take more time. The third one is to identify the sources which will enable us to accomplish this particular project or this particular business objective. Now this is done, and now from here, data identification of partial, and then from here, the data engineer will came in. Data storage, where and how we gonna store the data, and data processing, how we gonna process the data to produce the output that complement this thing. So these are the five major things that we need to perform in order to do the things. Now we stand on day three. Let's, okay, buddy. Before we proceed, let's take a break of 5 minutes, and we will be back. Before that, I will quickly check if somebody joined or somebody have any question here. Nope, that's pretty cool. Here, no. So let us start this. We still have a time. Anyone join her? You haven't voted. Here, anyone join? Bum, 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 bum. It's fun. Uh, Okay, guys, let's start with our 25th minute. So we are here. So we already discussed what is data discovery. So data discovery means to understand, do we have enough data that can suffice our need for that particular project or for solving that particular question that we want to solve. That's the thing. Okay. So the first one is again business value is simply to align the business that they are interested to invest into this one. So what kind of a value, business value means what kind of a benefit it can add to the value into the business. It's just a fancy way of saying business value or business benefit. Then identify your data consumer, then identify then these three are majorly for data engineer and data scientist, data architect. These three people gonna work on this one together. Okay. Your CDO, chief data officer, he is responsible for this one and this one. Then these three are responsible for data engineer, data architect, and your data scientist, and at the end data analyst. When everything is done, you're going to represent the previous and after scenarios to the business holder to justify what CTO said and what is actually happened is done properly or not, so like a neutral guy. So this was done. So data discovery we already completed this one, and let's quickly move to this one. This I want to write more on this one, but right now, right, I'm not going to patch it. So this we have identified. So these are the question I want to write it down somewhere as a structure or as a Bible or a guide that has to be followed properly. Every answer has to be answered properly. Every question has to be answered properly, so that we don't ever get ourselves into a scenario where we feel like, okay, everything was done, but we missed this when we thought it is not important enough. And on suddenly you get to know that this is really important, really, really important, and it started hindering the overall progress of the project. Let's quickly go here. Now, today we're gonna get into the subsection of foundation rule and concept, that is AWS data services and modern data architecture. Okay, what we're gonna learn about is AWS data services. So these are the service which is related with the data and what is gonna be modern data architecture. So we're gonna learn more a lot in the infrastructure of the AWS. Okay, within organization, team often build data solution in isolation and have their own data ingestion, storage, management, and governance layer. This was I was talking about. You're a data engineer when you use your own product. Okay, like Python code you are writing to do the process. Then you are using the premise-based data storage and everything. This lead to delays and increase the cost of data-driven decision. It also prevent the deeper insight that come when an organization analyze all their relevant data together. So this is a prime example of data silo, data isolation, or the process isolation. You have so simple. If I have to define is what happened here. You as a person work in an organization, this is the building of the organization, multiple floor. You work for this floor. That means you work for a team in this floor. Okay. You use this data set to create your own pipeline of data ingestion, data transformation, data loading. And using this, you are throwing the data into multiple output to multiple end user on multiple platform like Excel, then file, then database, then visualization tool, etc. This is good. This is really good. Okay, but the problem is this could have increased the overall value or experience of a user if he has used the data from other floor as well. Okay, so if you restrict yourself to a certain data set and not utilize the other factors as well, you might not get the overall picture or the picture that may be more in depth, right? So this is something that it is saying avoid these challenges. You must build a modern data architecture for analysis and insight that break down all the data silos that was I was talking about data silos, including third-party data. This architecture create end-to-end governance, put the data in the hand of everyone in the organization. The modern data strategy uses technology building block to help you manage, access, analyze, and act on your data. What does that mean? Modern data strategy uses technology building block to help you manage, access, analyze, and act on your data. What does that mean? Modern data strategy uses technology building block. What is technology building block? To help you manage, access, analyze, and act on your data. So a modern data strategy uses technology building block. Okay, technology building block to help you manage, access, and analyze, and act on your data. Let's see. Building block roughly correspond to a basic workflow. Choose the number marker in the following diagram for the description of each stage. Okay, the first one is ingestion. Let me click it. Data of the various type and from multiple sources is ingested into the system. Okay, stored data is stored in the centralized repository rather than in departmental silos. Agreed. Cataloging data is cataloged, indexed, and tagged to facilitate search and retrieval. Okay, perfect. Makes sense. Process. Much of the data in the raw form is not usable for analysis. In the process stage, data is transformed into more suit usable format. Okay, it makes sense. Catalog is like data is cataloged, indexed, and tagged to facilitate search and retrieval. Okay. Delivery for the consumption process, data is delivered to the consumer and a stakeholder for visualization and analysis. Makes sense. Security and governance. Entire data analysis system depend on the following: security of the data in transit and at rest, control access by authorized user only. Makes sense? The security of the data in transit and at rest. The following is a partial list of AWS services that can be used in the data analytical system. Some services can be used in multiple workflow. Okay, data lake that will come to the storage. Before you get, before you can ingest data, you need a place to put it. Makes sense. Therefore, a modern data architecture start with a data lake. A data lake is a centralized repository that you can use to store structures and structure and unstructured data at scale. Organization can use it to ingest, store, analyze diverse data set without the need for extensive processing. Makes sense. And the prime example of is Amazon S3, that is called Amazon Simple Storage Services, provide an optimal foundation for data lake because it because of its virtually unlimited scalability and high durability. You can seamlessly and non-distribute disruptively increase storage from gigabyte to petabyte of content and only pay for what you use. Perfect. Okay, for ingestion. Okay, so before I move, I want to to answer a few questions on this one: AWS data services and modern architecture. So what happened? We already know that we, as a data engineer, or when this entire data discovery process is completed, okay, data engineer will come and they will do their thing. So data discovery is just to understand whether we have the data to accomplish this project or their business objective or not. This is data discovery. Okay, and in the data discovery we have 5 steps that we need to follow one by one to complete the data. First one is business value. We need to understand what we are doing and how it's going to benefit the business. That's why it's called business value. So once business is aligned that okay, this is aligned with the business benefit or profit, so we are good to go. This is done. Then since we are doing something, that means we need to perform it for someone, right? So we need to identify the end user and then gather their information, that how many people are there, what the maximum number of people at once they're going to leverage it, what their expertise or what kind of formatted data they want. It with visualization, they want Power BI, they already have a Tableau Excel. So we can align on this thing so that we know at the end who gonna consume it. Okay. So first one is business uh, alignment. After that one, we will start with the end user. Who are the end user? Who, how they gonna access it, what they want, how they want to look like, everything. Once this is done, we're gonna work on this one, and then we will simply map to this thing. Perfect. Here we need to first identify that if this data has to be here, we need to get the corresponding raw data. So we need to identify the data sources. Once data sources is identified here as a part of data sources, we need to understand where we're going to store it. That means data storage, and then we will do data processing. It involves data to access this data, fetch the data, and ingest into the system. This entire three, four step process is called ingestion. Once that is available in the system, we will again read it, transform the data into something meaningful. This is called data transformation. And then we will simply load it to the end user based on our step number two, how they want it, what they're gonna look like. Okay. So once data discovery is done, entire process is done, what we need to understand how we're gonna do that. So we're gonna do using AWS services. Plus, we need to follow one modern architecture. Modern architecture. What modern architecture says that usually when you code, you simply create multiple functions to start creating coding, right? This is not how it's gonna do. Here we do a modular approach. Modular approach. So every responsibility of data engineer is being divided into multiple functions, and then one function calls the other function, the other. So it's like modularity. Okay. The first one here, two, three, four, five. Okay. The first one here is this one. What it was? Ingest. So as we learn, first one is ingest. We will bring the data from different sources into our data storage. That means for this one, we need a storage. Okay, we need a storage. Once we ingest the data into storage, then we can simply catalog it. Catalog. Catalog is really important. If you are not cataloging, there's a problem. Once cataloging is done, we know the metadata about this one. So at given point of time, once new person come, he knows where he need to search to get what kind of a data. Then he need to do is data processing, right? Data processing, cataloging, yeah, data processing. Then he do the data processing and ultimately it deliver it. It exactly is one: data ingestion, data storage, data cataloging, then data transformation, and then data delivery. These are the five things. So when I say multi-architecture, so every responsibility is being done into modular. That means one piece of code will do the ingestion, another piece of code will do the storage, then this, and this, and they will be called in sequential parallel order as per the need. So this is called a pipeline. When this is done, then it will go to this step, then this step, and this step, and finally the end user can digest the data. Perfect. For ingestion, there will be some AWS services. For storage, there may be some storage or something like this. Now imagine, as part of data discovery, we understood that data can be the data that we need for our usage. Okay, what kind of a data it may be. So when you talk about the data, we talk about three things. First one is data format. How the data is being available. Is it structured data? That means it follow a complete pattern. Is a semi-structured data? That means it follow certain parameter and then it doesn't. When unstructured data is completely no parameter data. There is no pattern data. There's nothing like pattern. Complete randomness. Okay. This is the first thing. Second thing for this one, I think, is to uh, data discovery, data sources, yep, data type, then data source, where it is being stored or where we gonna store. And the third one is ingest mode, how we gonna ingest it. Okay. So first one is data type, second one is data storage. This is I'm talking about from the source perspective. Where this data is available is in relation database management system. It is in the file, or is it in data lake, data warehouse, or in Excel? Where is it? Okay, and the last one is how it is being placed there. Is it batch processing, micro processing, or it is a stream, right? So the following. So research the different internal and external source where the data is generated and stored. This include database, application, and file. Data can be categorized along three line: data type, data source, and ingest mode. So how we gonna ingest it? Are we gonna do we need so see simple is data discovery means we need to understand the source. From the source, we understood one thing, that what kind of a data type is it. And based on this one, we need to understand where it is stored. And the third one is how we gonna ingest the data. If it is coming from IoT, that means we need to do real time based. That means it's gonna be stream. Or we can go micro batching. Micro stream, micro batching, micro batch, right? And the third one is batch one. Okay, so this is the one we have to do. But at a lot of time, we are not aware of the data type, or sometimes we know that the data gonna be of all three. It can be structure, it will be structure, it will be semi-structure, and it will be unstructured for different files that we're gonna leverage it. That means we need a universal storage where we dump any type of data. It doesn't matter, be it structured like Excel or this one, or semi-structured like JSON, XML, or unstructured like file, text file, or your video or audio, whatever it is. So this kind of a storage where you can dump any type of data set is called data lake. Okay, and AWS provide data lake as a web service, which it called S3. Amazon Simple Storage uh, Service, because it provide as a service. This is the one. So when you look the five modules of a data engineer, the storage, the Amazon provide it S3 initially. Okay, so once you have this one and you provide and you do the ingestion, the sources here, right? You created some code or some Python code, and then you extract this one, take a copy, and you directly dump it in AWS S3 bucket. Simply dump it here. All the data is available here. The best part of is when you can increase its size or decrease its size automatically. You don't have to worry. You only pay for the data storage you use. So you don't have to worry that tomorrow you have you thought like there's a limit of 100 MB. No, tomorrow you put like 1 GB or 10 GB or 1 terabyte or 1 petabyte, it will automatically increase its size based on your permission, and it will charge for the space you occupy. It won't charge even a single time more than that. That's the best part. Yes. So data ingestion is done. So out of five data ingestion, we know there is one type of storage that is called data lake, where you can simply dump everything. And why it is important? It is important at times or initially at the initial stage. Why? Because suppose there is 20 file system, that can help it. Okay, and you need to analyze it whether it is possible or not. If one file is in some other format, second is in another format, third is in another format. So how you can bring into a same place and then it can be picked by any of the person, right? In a team, it can be like a team of 5, 10, 50 people. But if you started accessing these 50 different sources one by one based on your requirement, it's not gonna help. Okay, suppose there are five different sources you identify that the data in this one, in any of this one, can be useful. Okay, and there are five people working here as well. Do you think if they want to check for source A, B, C, D, E, they have to individually go there every time to get the data? And this is done by all the five people. That means given a point of time, 25 connection will be formed. Okay, at worst case, like first guy, he connected to all file servers to bring the raw data and then start processing. Instead of doing this, what they did, rather than increasing overload into the source system, they goes there one time and bring the data into one place. From here, you don't have to make multiple connection. And reason is like if you have a software that connect to a database, that might not be help you to connect to a web service or some other places. Okay, that means you might need to have different software for different data storage or different data source or source data, right? So better you simply go once, bring the data and store it into a storage that is universally available for everyone. So only with one credential or one software you can simply go and read the data that you think it will be useful or not, or based on that one you can go and do the rest of the investigation. Okay, so we understood that for this kind of a data storage where you can dump any kind of a data, any type of data, this is called data lake. Okay, so this is the now in the modern architecture, everything is modular, and we understood the storage. There is one storage, specific storage that is called S3 bucket where you can dump anything. Now back to ingest. Now you know that this is the place I'm going to dump anything from any number of sources. Now you need something from AWS that can help them ingest. And what is ingestion? Ingestion is a process of bringing the data from different sources to your own data storage. Okay, a central data storage. And since you might not be, you might feel like the data type can be of any type, like it can be structured, it can be unstructured, or it can be semi-structured. So you use one type of data platform or data storage that can hold any kind of a data, and that is called data lake. But For this process of accessing, retrieving, and storing the data, this kind of coding, do we need to do it manually using Python or something? Or AWS provided? Since we are becoming AWS data engineer, that means AWS must have something for this one. After you establish the data lake, you can use specified or specialized AWS services to ingest different type of data into your data lake, or ingest different type of data, like different type of data into your data lake from different data sources, or from different data sources or data source. So first one is AWS Database Migration Service, that is called DMS. Okay. Second one is Amazon Data Firehose. Okay. This does this does resemble like what we thought. The third and fifth one is Amazon Managed Streaming for Apache Spark. So it's called Amazon MSK, Managed Streaming for Apache Spark. Okay, I need to understand. Or do we have more here? AWS IoT Core, AWS Data Sync, and AWS Transfer Family. So what it does, connect billions of IoT devices and route billions of matches to AWS services with AWS. Okay. What AWS Data Sync does to transfer data from on-premise file share object storage system and Hadoop cluster to AWS storage services synchronize on a schedule basis. Perfect. Automate file transfer into and out of the Amazon S3 using SFTP, FTPS, and SFTP protocol with the transfer family. And AWS Snowball, in case where transfer through a network is not feasible because of data volume sensitivity, use the AWS Snow family of purpose-built physical device. Oh, so they physically transfer the data. They transfer into some panda or something, and then that goes through to the other system. This way, you bypass the network, and the chance of hacking, basically it becomes zero if it is not being hacked during that file transfer. And now AWS database migration service. What is this? Database. Use AWS database migration service to load data from. Okay, so before I go for all this one, we are doing the ingestion. Okay, so we will get back to here. 5 minute of break will start. I will quickly check if someone joined on the stream. mm, I think nobody joined in the stream, so we are good. There's only one person. And anyone joined here? Nope, nope. So nobody joined here. Let me check this one. Nobody joined here, right? Okay, here as well, nobody joined. That's enough. Anyways, don't worry. It's just like I'm taking break for like 3-4 minutes. After this, we're gonna start our last session. I started a bit late because I was testing out something. So I'm sorry for that one. But today we have only two reading session. One is your revision session. So there is nothing much we can do today. Let's take a break. Mm. Someone join her. No one. Okay, so let's quickly start where we left. So far, we understood that as a data engineer, we are basically with the modern architecture, we are just modularizing our step. First one is ingestion, the second is storage, catalog, process, and deliver. In the ingestion, before ingestion start, I think storage. We need to decide on a storage, and since we not sure initially that what kind of a data these people have, so we will dump everything in S3 bucket or data lake to make sure that we have all we can universally dump anything that is being offered by our data sources. And how to dump it? Once we created an account, we created a specific location for this project, then we will simply do ingestion. For ingestion, AWS provide multiple services. First one is AWS DMS, that is database migration service to load data from relational and non-relational databases. So simply it will put the data from there and simply dump to our S3 location, I guess, or directly into some other data storage that AWS provide. For example, it provide Postgres, it provide database as service, or we can simply use the database of uh, AWS or Amazon directly. That is Aurora. Then is Amazon Data Firehose. Firehose simply you put every stream here and it will convert into it will merge it into one and simply stream out as individual. So ingest real time data stream with Amazon Data Firehose. Convert your data stream into formats such as Apache Park, Git, or ORC. Decompress the data or perform custom data transfer. But what's the difference between this and this one? Amazon MSK, that is managed streaming for for Kafka or Apache Kafka. Build fully managed Apache Kafka cluster for real-time streaming data pipeline and application. These are both the same. It's just this is more specific case. It's same as like one is to study and second one is to do PhD. You simply do masters, okay, simply on a particular course. But PhD you do on a specific thing. Similarly, Amazon Data Firehose allow you to do the real time data ingestion, but Amazon managed streaming for Apache Spark is specifically built for Apache Spark cluster for real time data streaming. But I think we will learn more as we progress. Now, if we have to collect the data from IoT, either we can simply write a Python code and do this one, but for this specific case, AWS has created already a software that we can use it, that is AWS IoT Core. Then data sync is like if the data is present into a file-based system, hierarchical file system or Hadoop cluster-based system, you can use AWS data sync to directly connect to that Hadoop and it will automatically talk to it and get the data to your environment. And then if this is the primitive source, it and the new file come, it will automatically sync it based on the scheduling time or refresh time. Then AWS transfer file. So it can automate file transfer and out into and out of the Amazon S3 using okay simply some places dump and you are like okay I need to transfer the file using internet. You can simply use SFTP, FTP and SFTP protocol to transfer the file over internet. And in case you don't want to involve the internet, you simply want the file to be transferred in a pen drive from one place to another, you can also opt for this AWS Snowflake services in case where the transfer through a network is not feasible because of the data volume sensitivity. Use the AWS Snow family of purpose build physical devices. Simply, they build a physical device and they transfer that using the physical device delivery. So we are done with two things: ingest and store. We will simply write it down here. What is it? AWS services within the organization to avoid the challenge. You must build a modern data architecture for analyzing and insight for analytics and insights that break down all the data silos, including third-party data. This architecture create end-to-end governance and put data in the right hand to the organization. Modern data strategy use technology building. So simply, this is the one you don't have to write that I learned here. So this is AWS services and modern data, modern architecture or architecture. Perfect. So what are the modern architectures? So if you look from the perspective of that one, what it does is simply modularize each and every step so that once this step is done, it will move to second, then third and fourth. So this way it becomes easier to understand where the data is actually failing and we simply have to work on that particular module. So to avoid the challenge, you must build a modern data architecture for analytics. This one, modern data strategy use technology building block to help you manage, access, analyze, and act as well. This building block correspond to a basic workflow. Choose the number mark. So modern architecture converts every responsibility of data engineer into a modular functionality which which could be performed by AWS web services provided by performed by AWS or Amazon services. So these technological blocks of module can re- represent the the action data engineer need to perform in orderly manner. Perfect. For example, step one, ingest. Okay. Step two, data storage. Storage. Third one, once data is there, everything is there, data cataloging. Catalog. Once we get the metadata about the data that is dropped into raw data, then we can simply using the metadata. We will because we know now about the data. Like if it's an Excel, we know the header, the number of column, number of rows. Then we can work on that. So it's become data processing. And step five is again now the data is being transferred from raw to meaningful. You need to do the data delivery, data ingest, Mhm. Data ingestion. So using AWS, we access, extract, and load data into our premise or our storage to increase to like why to centralize centralize data. Basically, basically, what do you think like centralized? What do you think if you want to do something or perform a project and you thought like every data will be present in a same computer? No, it can be present in multiple computers. It can be of multiple data type. It can be stored in multiple different softwares. Now, now, if the team of 10 or 15 people are working and they need to consume a data, that means they have to connect to a particular computer, then get the value or the data set, and then started working on that, right? But is it how the things work? No. Because if 15 people are working and they have to do this thing again and again, that's not the right way. Second, it will increase the overhead to those places, and each one of you need the access to that particular place. That means if there's 10 or 15 sources and there are 50 people that is gonna work on this in this project, that means you need to raise 50 different credential requests to these 10, each of these 10 data sources, and they won't give you. Okay, because it may lead to, it may breach the data governance. Okay, these people are not authorized. One person, we can understand the business has authorized you, but the people doesn't make sense. So what they do, like instead of creating this havoc, what they do, they give access to one person, and this person gonna go to different sources and they will bring the data into their system, a place or a storage that these 50 people can access it, because now this system belongs to these guys. But the problem is right now you have a theme, you have a project that you need to perform this one, and data can be available anywhere, and it can be present with any data type. And if you want to bring this sample data into your system to do the initial analysis that whether it will be useful or not, and you want to put every data in a single storage without irrespective of its data storage, irrespective of its data type, then data lake is the only place where you can dump any kind of a data. So initially the people use data lake and ingestion to bring the data from multiple sources and dump it there, and then start analyzing the data, that which data is useful and whichever is it, then they will get the formal permission, and they started creating the pipeline that automatically triggered and take the data from that place to into our system. So data storage again, data ingestion, no, this is for data storage. Using AWS Data Lake S3. Okay, now utilizing on Amazon S3 to load any data type, to load to load any data type and data access, centralized data storage. Perfect. So it become easier from that perspective when you need to access from the same place rather than going to individual data source again and again, right? Now, okay, nobody join. If somebody join, then I will do it. Let me remove it and let me add this to here. Uh, why? Yeah. Once I have a break, I will go and bring the file back this one. Meanwhile, then I will use. Okay. Okay. The third one is catalog, is to get metadata of the source data sets. Once we know about what kind of a data that we bought from these places, because initially we might not be aware of like what kind of the data we are bringing, what kind of data is stored inside it. So this will give that picture. And once this picture is clear, then we can do data transformation of converting a raw data into 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 meaningful information, right? And the last one is data delivery to transfer trans transfer these data or this processed data to the corresponding stakeholders. Stakeholders. This is the one we understood. So if you look from the catalog here, the storage is done. We also get the different AWS services that they provided. Okay, so if you look here for this one, for this step, Amazon provide what? There are multiple one. First one is uh, okay, Amazon relational database migration service. Then let me write it down. Relational migration service. Okay, this is the first one. Second one is uh, what's the name? Amazon Data Firehose. Mm, Amazon Data Firehose. Done. Then Amazon managed Kafka MSK or something. I forget the name. MSK managed streamed for Kafka. So, manage stream Amazon managed stream for Kafka or Apache Kafka. Apache Kafka. Perfect. Then if you have to access the data from if you want to like extract and ingest the data from IoT, then you can use AWS IoT Core. AWS IoT Core. Or if you want to transfer the file from the file system in a computer, you can simply use data sync, I guess, if I'm not wrong. AWS data sync. AWS data sync. Sync. And then AWS file transfer. Simply transfer file through internet. AWS file transfer. And the last one that offer family transfer family. Just transfer family because transfer family. And then AWS snowball. AWS snowball, right? So it transfers the file or the data set physically rather than using the internet. For data storage, we have AWS Data Lake, that is S3 simple storage services. Then the second one can be AWS Relational Database Service, or the inbuilt database provided by AWS is Aurora. If not, it also provides the NoSQL database. That is your what's the name? I forget. DynamoDB. DynamoDB. And then it provides the Amazon data warehouse called Redshift. For cataloging, AWS provide two major things. One was AWS crawler that will read and bring the metadata, and it will store this into AWS Glue metadata or catalog. Let's see, catalog. An essential component of the data lake. It is working on the data lake. Okay, data lake on Amazon S3 is the data catalog. Organization can use data log to keep a track of data set and understand what data exists, where it is located, is quantity, quality, and how it is used. A data catalog is a design to provide a single source of truth about the content of the data lake. The problem with the data lake is like anyone can dump it, and the problem is like if you started dumping like anything, it will become a pile, and it become hard for you to know where is that exact garbage that you throw, right? So that means at given point of time there should be one person who should be writing down who, where, when, and what type of the garbage through, and it become easy to track that way. And this is something AWS does for its data lake, and it will prevent this way, it will prevent the data lake to convert into data swarm. So AWS Glue data catalog create a catalog of metadata about your store's asset. Use this catalog to help search and find relevant data sources based on the various attribute like name, owner, business term, and other mixes. Now processing service. Now so far we are done with bringing the data storing, and then cataloging to understand whether the data came or not. If came, from where it came, who is the owner, was the privilege. Then we need to get into depth. What format of the data? If it's Excel, what's the attribute? What's the number of column? What's the number of rows? So based on that one, then we will work on processing part to understand how to access this file format, what kind of a data we need to access, and then to understand which one will provide us the best result for this. So after the data cataloging, it can now be processed or transferred into format that are useful for analysis and insight. The transformation can include type conversion, filtering, aggregation, standardization, and normalization. There's multiple things you can do. And now, I mean, these are the services that it provides for data processing. Three is there: Data Glue, Data EMR, sorry, AWS Glue, Amazon EMR, and Amazon Managed Services. Okay, so we have that Apache Spark for data ingestion, right? For streamline ingestion, it was Amazon MSK, right? Manage stream for Kafka because it is managing the stream. Here, managed services for Apache Flink, successor of Kinesis data analysis, much more with this one. So use AWS Glue, a fully managed extract, transform, and load. Use a fully managed. So it provide ETL as a services. Okay, now I understood. So it provide the job. Okay, it's like a talent. Makes sense. AWS Glue is nothing but a talent. It provide you extra transform and load ETL as a service. A fully managed ETL service prepare and clean data from various sources for analysis. It helps classify data, extract schema, and populate data catalog. Perfect, perfect, perfect. I think I understood now. AWS is your ETL tool that Amazon provide as a service. Okay, then what is Amazon EMR? With Amazon EMR, process big data set using open source framework, customize Amazon Elastic Computer Cloud, Compute Cloud, EC2 instances, Amazon is Elastic Kubernetes Services, Amazon EKS, AWS Outpost, or Amazon EMR Serverless. It can be used to run batch job or data processing. But what is Amazon EMR? Process big data set using open source framework, customize Amazon Elastic. compute cloud. But what is EMR? I need to understand. Let's go to the cloud. East and West. Nowadays, AI is the best. So let me ask it. What is Amazon EMR? He said night owl, dude. He said night owl. See, hello night owl, dude. That's not bad. I know, but nothing can be done. Okay, let's quickly. Amazon Elastic Mapper Reducer is a cloud big data platform from AWS that makes it easier to process and analyze large amount of data using open source framework. What it does, EMR let you run distributed data processing job across a resizable cluster of virtual machine, handling the heavy lifting of provisioning, configuring and tuning the infrastructure for you. Key framework it support Apache Spark, Apache Hadoop, Apache Hive. Okay, Spark work on top of the fast in-memory data processing. Hive, Apache Hive, SQL like query on big data. Perfect. Apache HBase. Oh, no SQL database on Hadoop. Dude, I work on everything, but but I'm not a pro. I need to get my hands on again. Then Presto, no, Flink, real time stream processing. No, dude, these two things I haven't done. But I heard of Presto and Flink. Yes, I did that. It's not that gonna be tough. It's just one of the services. Instead of Flink, you can use the Kafka, Apache Kafka, right? Common use cases ETL, log analysis, machine learning at scale, geonis, genomic and scientific computing, data transferring before loading into the data warehouse like Redshift, data transformation. How it works, you define a cluster, master node and worker node, EMR provision as is EC2 instances automatically. You submit your Spark or Hadoop jobs. Results are stored in S3, SDFS or any another data store. You can terminate the cluster when done. Pay only what you use. Ah, now I got it. I got it. Got it. Very well. So thing is like when we have large amount of data that cannot be processed into single instance, you need multiple instances. You break that data to provide into multiple instances and then run it. But to run it and coordinate it, you need a particular type of software that coordinate like this. This is called mapper and reducer. Okay, prime example of on-premise is Apache Hadoop that let you store the data in SDFS and then it process this data using uh, at the backend mapper and reducer. Okay, and you can also do Apache Hive that let you do a big query like SQL like query on big data, and then you can also use Apache Spark. Then you can use Apache HBase in case you have the file in JSON format. Okay. Then Kafka again for real-time based processing for multiple distributed systems. So EMR provide you that infrastructure, and then it will let the software sit on top of it and then execute it on this platform and get you the results. Perfect. 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 So what it does is simply replicate this thing. E framework it support. So it has Apache Hadoop, Apache Hive. So at the base, it is using its infrastructure to host these applications or these softwares, and then let you do the data storage and data processing. Answer is very simple. You do so. What happened initially in your computer? You create in your organization or in your building of office, you have multiple computers. You join it and you make one computer as primary node and then use this to do the distributed system and you process this one. Now Amazon what it says, let us do this one All you have to do is work on client service server base. You simply send a request. We will automatically decide how many cluster the computer we need to process this one, and we will automatically handle this thing. We will install Hadoop, Hive, HBase, Spark, Flink, or Presto or Trino. We will do that for you. You don't have to worry. You simply pay for what you have to do. Okay, you bring the data, you process it, you get the output done. We will charge you for this entire process. That's it. We won't charge you a bit, even a single money after that. But if you do the on-premise, you have to pay for the electricity, you have to pay for the rent, you have to pay for the machine you need to buy. So one time setup cost is high, then the maintenance cost is high, then there's no there's a chance that you might not be able to store its multiple instances. So in case it goes down, the entire system is down. But not like AWS, it have multiple instances running at different part of the world. So if even if one is down, other will be running. And the best example of is right now, one of the uh, place it has a center. It was blasted during the war. They shifted its traffic to other places. So suppose every data set was stored in that particular in that particular storage or the place, everyone might have lost their data. But it never happened because even if it was destroyed, the data was gone. Its replica was stored in the other part of the world. That means you are safe and sound every single second. Okay, so EMR is done. Let me quickly do this and then we will end this session for today. Quickly author SQL. Quickly Amazon managed services for Apache Flink. Flink is again streaming. When you perform streaming on distributed system or using distributed system or distributed processing system EMR. So quickly author SQL code for real-time data processing using Amazon managed services. So manage the services. It doesn't provide the services, manage the services because it's already existing. I'm pretty sure. Uh, Task including filtering, aggregation, joining, delivering. Okay, I can write down, but let me ask this question to this guy. Why it is called for Apache Flink? Amazon simply indicate the AWS Web Service product. Managed services is the key part managed that I want to understand. This means AWS handle all operational heavy lifting for you, provision, configuration, infrastructure, patching, and updates, monitoring, health check, automatic scaling, backup, and fault tolerance. It will do everything for you. You just write your application code. AWS manage everything for you. That's what I was talking about. You just have to send a request what you want to do with the data set, and they will take care of the infrastructure setup, is replica to avoid any data loss. Everything. Apache Flink is an open source framework running under the hood. It's a powerful engine for real time processing, stream processing, process data as it arrives, stateful computation over data stream, perfect low latency, and higher output data pipeline. Why not just call it as Amazon Flink? Because AWS did not build Flink. That's the thing. It's an it's an open source project maintained by Apache Software Foundation. Calling it managed services for Apache Flink is both honest and clear. Naming pattern MSK, this one, and open search for open search. Okay, and EMR is for Hadoop, Spark, and etc. So one thing that I want to understand here, difference between Flink and Kafka. Is it Kafka is messaging tool like IoT or something? Great question. Apache will together. But Apache, Flink and Kafka are often used together, but they serve very different purpose. Here's the clear. Kafka, highway, road, and process effective. It moves data from point A to B reliably. It takes the data and does something intelligent with it. What it does? Primary purpose, manage broker, data transfer. Message broker, it transfers the message, streaming, processing, or computation. What it does is store and stream message, store and stream messages. Okay, it stream the message like Solace, process and transform data, a pipe, a brain, data storage, yes, retain message log, no process and pass on. Okay, Apache Flink do the stream processing. So when the data is continuously coming in the real time, it just simply uh, read it and processes minimum. Kafka streaming is basic, very powerful and complex. Very low, very low. Kafka is great for publishing and subscribing the data stream like message queue, right? Messaging. So Kafka is messaging, and this one is for streaming, buffering data between system decoupling, and this one. It's like aggregation on this one. Honest how they work together. In most into like data source, Kafka transfer, transport, and buffer, Flink process, analyze, output. Now I got it. Now I got it. Kafka and Flink. Kafka is like ingestion. It bring the data for you, transform the data. From that ETL we use for data processing, here is the Flink. Now I got it. So in the first part, let me quickly do it. And we have very less time. So, so in the first, what we do ingestion, then store, then catalog, and then process. But if you look at its ingestion mainly and processing, right? For batch one we have ETL, okay, that do the ingestion, that ETL here, that do the processing. But for ingestion we have different AWS services like file transfer family, right? Using through internet, then through the devices to bypass the internet is AWS Snowball, right? Then what else we have to to ingest the data? Uh, mm, Amazon manage service Kafka, right? Apache Kafka. Here it was ETL. There should be Flink as well. All right, now I got it. There is manage service for Flink, right? And then EMR is also there, and there are many more. So Kafka is used for ingestion to move the stream data from one place to another, right? Data. Because the stream data at the same time we use the Flink. You got it? I got it. This is so interesting, dude. I never thought like this. This is so easy to understand if you. uh, Okay, for delivery, we have. I'm going to do it again tomorrow. I need to write it properly tomorrow. So I'm going to come here. Transform data. Transform data is delivered to consumer and stakeholder. Delivered to the consumer or stakeholders such as data scientists, data analysts, and business analysts. This primary purpose of the data analytics is to extract insights from the data that can lead to good business or organizational outcome. Many AWS services can be used at this stage. Oh, Amazon Redshift can directly analyze large set of. How come it's delivered? Okay. Amazon Redshift can directly analyze large data set of structured data across many functional databases and data sets without moving the data. Okay. But if I remember, Redshift is warehouse. So it provides you with the different functions that can analyze the data and get you the insight out of it. Perfect, makes sense. But it's not interactive. It can give you the data set, but it won't be interactive like Power BI, all this. Perfect. Now on Amazon Athena, I worked is that it directly run on the data set that is placed on your S3 bucket. So query large data set directly on the Amazon S3 using standard SQL syntax in various formats such as CSV, Parquet, and Output. I was right. So Athena allowed you to access and run the SQL based queries directly on the files on your data lake if they have the format of like tabular structure format like CSV, Parquet, or ORC file. Then Amazon EMR is Elastic Map and Reducer is it does allow you to process the data. So Amazon EMR to run analytic framework like Apache Spark, Hive, Presto, and Flink on large data sets stored in AWS services like Amazon. This one, including log analysis, machine learning, data science, web indexing, and scientific simulation. So basically, what is happening in this one again is same as processing. Once you convert the data into meaningful information, you can simply do visualization to understand that. Second thing, instead of data processing, you did the data processing with this one. Instead of data processing, what you do, you simply run it and give the output, deliver the output. That's exactly you do, right? So you can do two things. One is convert the raw data into process data. When this process data, you can use it to deliver the insights. How? Again, processing it. Second thing, you can simply directly process the raw data and give the output as a delivery to the person bypassing the processing layer. Then Amazon database is a service used more than 14 purpose built Amazon databases to store, query, analyze large data set. Choose from relational key value document in memory graph, time series, wide column, or ledger database. Just store many datasets. Many datasets. You store it here and then you simply run the queries to extract the insights. Deliveries, one thing, processing is like sometime you might not because S3, what is S3? Is simply file any dump file. Okay, you cannot simply do anything. What processing does, it will take all the data set, transform it in a format that you want to store into a software where you can use more functions, more complex function with ease to get the output. And it storage can be warehouse. You can keep it there. You can simply use Athena to process this file and directly load this one, or you can use the EMR to load this data and do the Spark run all this one if the data is so big. So based on the raw data you have to decide how you want to process and where you want to process things. How you want to process and where you want to process is completely depend on architecture now. And architecture is totally depend on the demand on the data set we have, right? What output the user want to see and how it want to see, and then what kind of a data we have and what kind of processing we do it. Based on this, you need to decide the architecture. Sometimes what happen like the file is small and CSV file is coming. Architecture will be simple. You're gonna simply use since it's a batch file. They will drop it. You will take it at a given point of time, right? So you need file transfer. So you can use the Amazon file transfer fabric, right? You simply transfer the file through internet and dump it in S3. Now our logic very simple. The user is we. As a developer, we are the user. And we need to analyze the data and know that the data format can be CSV, Park, and ORC. That means we don't need to use any of the services. We will simply use Amazon Athena and simply query these files using uh, Athena query or SQL query, and it will give the result. Because end user is us at this moment, and we can use this thing to get the result. Okay. Now, now the thing is, our end users are let's say, um, okay, let's suppose our end user are our my director, and he says that Nitin, come here. I want data about the trend. And since I want the data about the trend, I want to see it in a very visual form so that I can discuss it with other stakeholders. So I was like, okay, but as far as I understood, this data is in terabyte, a petabyte. Okay, so what I will do, I will some first bring this data from multiple sources, and I know this data is stored in relational database in warehouses somewhere. So that means it's a batch-wise system. The data got dumped one at a time or at a particular time. It is not coming randomly. It is coming at a specific time. That's why it's batch. So that means I can simply go and use one ingestion service of AWS that can simply go there, took this file and put that into S3 bucket. So I did the same. I use what kind of I can use. It's manageable to transfer the file. So suppose I use not migration, real time. I don't want Apache Graphs. I don't want. Okay, I want data sync. I want to transfer this from my on-premise to this one because it's very heavy. It's same as Hadoop cluster. It's very well. So I'm going to use AWS data sync that will directly connect to my on-premise and put the data to my wherever the file is and transfer it directly to my S3 bucket. Now the data is in petabyte. If I use a processing file like this one, this one, Athena and other is gonna die. And even data warehouse gonna die because the level of processing I want to do, the level of insight I want to do is really big. And if I give this to Redshift or the data warehouse, it will be able to do it, but it will take a long time. And I don't want that one. Then I realized I can use distributed system map and reducer logic where a file is broke down in small files. It is stored in different nodes or different computer. They are processed and then the solution or answer is patched together and written back to me as a single file. Okay. For me, it's the same computer doing that one with whom I'm interacting, but at the back, the file is broke. It is being torn apart into smaller files and multiple smaller computers were running process this one and ultimately patching and then this computer with whom I was talking it gave me the result, right? This way, since is doing the parallel processing on the file, time will reduce drastically and I will get the answer. And once I get the answer, I will send this file to my data analyst. And data analyst can use Power BI, Tableau, Excel, any form of the data visualizing tool he can think of, he feel like is better as per my director, he will do that. So now you understand that my entire architecture that I was talking to you guys right now on real time is completely made based on the requirement. I'm not making out the things, right? I understood my director need this data. This kind of a data is available on premise in Hadoop system. This data size is very big. I cannot use any service to do that one. So to bring it, I use AWS data sync into my S3 bucket, and using S3 bucket, I run the data is in S3. I run directly another AWS services that is EMR. Provide the files wherever the file is. It will automatically take this file, break it, put it different nodes, access, process it, and give me the output and store the output in S3 or wherever the location I want. Then I will ask my analyst to directly take this file from here. Or if you want, I can put it into in some database or something. It will be there. It will simply connect to the database. It will read that database file, process it, put it into Tableau or Power BI or Excel, create beautiful looking dashboard or pause, etc. And my end user, my director will be easily able to see the trend and he will be happy. I am happy. Project done. I was selected money. Then I need to look for another project so that I can build my time. Okay. Now database is done. Amazon Open Search Service. I don't know what is it. Deploy, operate, and scale Open Search cluster in AWS Cloud. Analyze large volume of data from various sources like Amazon Kinesis data stream. Okay, Kinesis data stream and its successor become Flink. If I'm not wrong, it does. I does successor to the Kinesis data analysis is Apache Flink. Yep. Data streaming has three. Amazon DynamoDB is NoSQL data storage that Amazon provide. Visualize, analyze large data set using SQL chart. Same thing. Amazon site is simply enable you, not enable you to analyze large data set using SQL query. If the data is stored, simply it will be stored here, then it will allow you to do this kind of visualization. I'm sorry. Amazon SageMaker build, train, and deploy machine learning models for. I think I have seen this one SageMaker. So it will enable. So now data is in my S3 bucket and is literally a huge data storage. Since it's a huge data storage and unstructured data can be stored there, I can use my machine learning algorithm, and AWS can provide me a stage where I can simply execute my machine learning algorithm or my code there, and it will directly access to S3 bucket, get my files, read it, and since all this one infrastructure, computation power, storage, everything AWS provide, all I provide is the file location, the code I want it to run, and the output that I want to store and where I want to store. So infrastructure part it will take care. If you do it on your computer, trust me, your computer will die. If you don't have like cluster computer or you have very powerful computer, but for that one you need to give money one time, and that's a huge cost. And now the governance secured in data analytics system refer to a measure taken to protect data from unauthorized access. Breach of attack of this one governance and the AWS data formation. I know about this one. So is management services, AWS key management services, I don't know. AWS audit manager, AWS data zone, I heard this on this one, and this will come now. But this is something we gonna do it tomorrow as well. We're gonna read it again as part of your recap. I think tomorrow again I will do this thing. I don't know why, but yes, I will do it, and I will write down the things. And with this, I think we will wrap today's session for this one. And don't think that we're gonna over. No, we're gonna start another live stream, and that's where we're gonna learn about Postgres. And it's gonna be for 1.5 hour or 1 hour. I was thinking 1.5 hour. Yeah, I will do it at least 1.5 hour. So it's gonna be 3:30 to 4:30 and 5 o'clock. And 5 o'clock I will close it and then we go to sleep. So let me check if anyone has a question. Anyone joined? Let me quickly see it here. Nobody joined. 2 hours done. I was watching. Perfect. Anyone on Twitch? One guy, and that's me. Okay, guys, with this, I will stop here and I will see you tomorrow every 12:15 or 12:30 around this time. So 12 to 1 in between this time, daily I'm going to do stream and learn things. Okay, this is my ultimate chance. I have to do it. Okay, take care, guys. I think someday I will sit and talk about a lot of things when